Hello and welcome to this video of cnVision configuration overview. My name is Chinmay and I work as a systems engineer for cnVision and EPMP portfolio at Cambium Networks. In this video, we are going to go hands-on from configuring the radios to establishing a wireless link to creating a network which is kind of similar to the actual network in the field. So let me first walk you through the connections and then we are going to go take a look at the screen record which will show you the network topology, cameras, VMSs and cnVision web UI. So we have this PC on which video management system server is running, which is connecting to this hub via this PoE. So the PC is connected to the gigabit data port. Data plus power port is connecting to the Hub 360. So Hub 360 is connecting these two clients, Client Macro and Client Mini. So below Client Mini, which is on the Ethernet side of the Client Mini, goes to the gigabit plus data, gigabit data plus power port of the 30 volts Cambium PoE. The data port goes to the cnMatrix switch, and the other port on cnMatrix switch, which is PoE out plus data port, connects to one of the cameras, which we call camera 1 in our topology. And the client mini, which is also connected wirelessly to the Hub 360, connects to the Cambium PoE gigabit data plus power port, and the data port goes to the data port of the camera, and this camera is getting power from this AC to DC adapter as it has two ports. So that's how the connections look like, and uh, along the line I will also make you familiar with very useful features of cnVision from the perspective of video management system and cameras. So let's go to the next segment where I'm going to show you the screen record of web UI of cnVision and everything else.
Let's begin this segment with going through the schematic of the network topology that you just saw on the table. So PC1, which is the laptop, is connecting to Hub 360 via the Cambium 56 volts PoE. Then two clients are connecting to the hub wirelessly. Camera 1 is connected below client micro, meaning connected on the Ethernet side of client micro via the cnMatrix switch. On the other side, for client mini, camera 2 is connected directly to the client mini via this 30 volts PoE. So uh, we are doing this just for the demonstration purpose that you could do it either way. If you have only one camera, you can connect directly to the data port on the PoE, which goes to the client. Else, if you have multiple cameras below the client, you can use the switch and have multiple cameras connected to the switch so that they will connect to the client from its Ethernet side. So first and foremost question that all of you will have is how to make wireless connection between clients and hub. So answer to that is very simple. You don't need to pre-configure anything. All you need to do is power up the radios, hubs, and clients will connect to the hub wirelessly because default WPA2 pre-shared key is the same for all cnVision devices, so that they will do the scanning. When client comes up, they will scan all the channels and they will look for cnVision hubs, and the moment they find the hub, they will try to connect, and if the WPA2 pre-shared key is same, then they will connect to the hub. So that's very simple. You don't have to do anything. So all you will need is I mean, one of the options that you have, which which is typically done by many people, is have the DHCP server running on the Ethernet side of Hub 360, let's say somewhere here, so that when everything powers up, uh, Hub 360 receives IP address via DHCP server, and when clients connect wirelessly to the hub, they will receive the IP address, and so on and so forth. So such that the cameras, if they are set up to receive the IP address via DHCP, they will receive the IP addresses as well. The One of the other options is to pre-configure the IP address of the devices statically. That's exactly what I've done in this example. So I have hub pre-configured at 192.168.0.1, client micro at 2, mini at 3, camera at 4, camera 1 and camera 2 at .5. So let's take a look at the web UI of the cnVision. So this is right now the screen that you are seeing is the screen of the PC1, on which we have WiseNet video management system server running. That server can be accessed via WiseNet client, and we are going to be accessing cnVision web UI from this PC as well. Okay, so when I log into this IP address 192.168.0.1, here's the web UI of cnVision, to which I log in using credentials to see the status page of the cnVision Hub uh, web user interface. So, so I have powered up Hub as well as clients, so that both the clients can be seen connected to this hub in monitor wireless. So you can see here client micro at .2 and client mini at .3 is what we see in the topology as well. So we are gonna come back to this menu monitor wireless and talk more about it. So before that, let's do it one by one. Start with the status page. So status page of any cnVision device, be it a hub or the client, shows the current download speed and upload speed. So right now we don't have any data flowing. That's why you see very small speeds at this time. You can also see this in monitor and throughput chart where you don't have any data actively flowing. So of course you will see this speed going up when we will we will get the video feed from the cameras, say whenever we will start the client, and whenever we will request the video feed from camera 1 and camera 2, it will the stream will flow from camera to switch to client to hub, and from this side from the camera to client to hub, to the PC, and all the way to VMS server. Okay, so the first section is where we show the download and upload speeds. Next to that uh, is the list of cameras detected. So that's the best part of this cnVision uh, solution, that the cameras are not only detected on your video management systems, but they are also detected on the cnVision devices. So you can use it as the additional tool to troubleshoot. So for example, if you are not able to see the video feed on the VMS, first thing you can think of is, hey, so let me log in to the web UI of the radio to which the cameras are connected and see whether I can see the feed or not. So that can be useful feature for troubleshooting. Next feature we have is capability to stream the video. So not only we can detect the cameras, but also can do the video stream of the detected cameras by clicking here on video stream button. So you click there and then enter the credentials. and then it takes a few seconds to load the video stream. And now you can see that we can have the video stream running on the cnVision web user interface as well. I'm just quickly gonna move the camera so that you can see the live stream moving as well. So that was for the camera connected below client micro, I believe, and the other .5 camera which is connected below client mini. Let's try to stream. Okay, so this way we are able to detect as well as stream both the cameras on the hub. Third and even more important feature that we offer is VMS integration, which is a video management system integration. So let's go look at all the options. So here is, so whether you want to use this feature or not. If not, you can keep it disabled with enabled. uh, right now we have successfully integrated two VMSs, which is WiseNet Wave VMS and Milestone XProtect VMS. So currently, uh, as you can see in the schematic, we have WiseNet VMS server running on this particular PC, and very soon we are going to see how this VMS integration works. So in order to do that, I have downloaded the WiseNet Wave video management system server from their website. Let me show you. Yeah, here. So you can download and install the server. So that server is running on your system, and then you can download and install client to access that particular server and show all kinds of stuff like cameras, etc. in your video management system. So I have that client open here. Uh, and so I'm going to connect to the server which is running on my PC. So the IP address of my PC right now is 192.168.0.252, as you can see here. Yep, this one. So here, as expected, we see the cameras which are connected. So this USB integrated webcam is the webcam of my PC, and then Dahua and Amcrest are the cameras which are connected to the clients. So they are getting detected on the VMS as everything is in the same broadcast domain, so that camera are not only detected on cnVision but also on the VMSs. Okay, so before we begin with VMS, let me quickly go back and show you that uh, these exact same cameras are detected on the clients as well. So the way it works is, uh, so as you can see here, everything is in the same broadcast domain. So the way cameras are detected on video management server is VMS server sends the on-wave discovery packets, or whichever protocol it works on, discovery packets which on as a broadcast packet, so they reach all the devices in the broadcast domain, uh, and cameras being part of the broadcast domain, those packets reach the cameras, and then cameras respond. They send back discovery response packets back to the VMS, so that the cameras are detected on the VMS, and along with the discovery response packet, inside the discovery response packet they have the information about how to stream uh, the video from that camera as well. Exactly same thing we have on our cnVision solution. So we have enabled on-wave protocol in our cnVision software, so that cnVision device sends out the on-wave discovery packets which reach the cameras, and cameras responds to it with the response to discovery packets, so that they are detected on cnVision web UI, and you can stream the cameras as well. So that's the reason why you see the camera one not only on client micro but on hub as well as client mini, because they are all in same broadcast domain. So all the cameras are getting detected on all the cnVision devices. In next firmware we are going to show it in the tree form, so that you will be able to see all the cameras in so you will be able to see which camera is connected on the Ethernet side of which client, so that it's not confusing. So for example, right now if you go to this particular client and you see both the cameras, and you don't know right now which camera is on the Ethernet side of this client mini and which is on the Ethernet side of client micro. So in next firmware we are going to show you the tree view, so that you know which camera is connected to which client. Okay, so with that, let's continue with our discussion with the VMS. So, uh, I'm using this WiseNet Wave VMS client in order to access the server, and everything for the sake of convenience is running on the same PC. Uh, you will typically have it running at different places, meaning so this is oversimplified topology of what you have actually in the field. So in field, you may have something like VMS. So hub will connect to, I mean, hub will connect to some switch, and your VMS server may be in same broadcast domain or in the routed network, which is internet. And you will be accessing the client from somewhere like from your office or your house by using the client like a WiseNet wave client or any other VMS client. So that's most likely the typical scenario, but here just for the sake of this video, everything is running on the same machine. Okay, so as you can see here, I can see the exact same video stream that we saw on uh, cnVision web UI. So we have these two cameras streaming. So that's typically what you generally deal with when you deal with the camera. So what's there in cnVision solution to integrate with the VMS? So what this does is, so when you configure the all these parameters for the VMS, like which type of VMS you are using, and you are going to send an events to, then the IP address of the VMS, the port on which the VMS is listening, and the credentials to log in to VMS. So when you have these parameters configured on your cnVision device, it can be client or a hub, then that particular cnVision device is capable to send uh, alarms to the VMS, just like you get an alarms uh, from the cameras. So you are typically used to configuring different events so that when those particular events occur, they trigger an alarm which is sent to the VMS and it is displayed on the VMS here in notifications. So by doing this integration, what we are achieving is, let me show you an example. So right now we have two clients connected. So one of the events that will trigger an alarm on the VMS is if client disconnects from the hub. So there are different events. So if client disconnects, or if clients connects back to the hub, or if hub reboots and when the system is up, hub will send a notification to the VMS saying that, hey, I am up. So there are different list of events, which of course we will have it in our user guide to see what all events are there which are capable of triggering an alarm or on video management system. And we are also open to take the request. So if a particular customer requests that, hey, so for this particular event or an activity on cnVision device, I need an alarm. So we will be able to uh, uh, fulfill those requests as well. So as of now, uh, or one of the important event that anyone would want an alarm for is if the client disconnects. So let me trigger the disconnect manually by hitting the deregister button and see whether it shows up uh, the alarm here or not. Okay. Okay. So now that I have deregistered, I see here custom event operator initiated disconnect. So this particular event is sent to the VMS by the hub, that a particular client got deregistered from me, and you just saw that event here. And right, so I just deregistered it and I think it just connected back, so that when it connected back we saw a new event saying SM registered back. So let's see. Yeah, let's give it a second for it to show in this table. I already see registered clients got updated to 2. Okay, so it just took a few seconds to show up in this particular table, but it connected exactly at the time when you saw the notification here saying the SM registered. So notifications come here and they stay here only for a few seconds and then they go to the alarms. So these last 3 events, which are this one, operator initiated disconnect, where the one when I hit the deregister button, and this generic event saying new SM registered, uh, is the event when that particular client connected back to the hub. So that's the cool feature, very cool and very useful feature that we have uh, as a part of our cnVision solution, that we are able to do the VMS integration so that cnVision device is capable of sending an event that triggers an alarm on the VMS so that you know that something happened on the cnVision devices. One more feature that we have here is uh, uh, cnVision Statistics Preview on VMS. So what that, in order to see that, you need to click on generate link that generates this link and then copy and under web pages go to new web page and paste it in the URL and name. You can name it anything you want. I'm gonna do it cnVision Hub 360R. Okay, so that brings this style view of some of the statistics on Hub 360R. So I mean, you can close it and then open it again, where you see all those statistics. So it shows the device name and what amount of traffic is flowing on the downlink, which is right now almost nothing, and you have a lot of traffic on the uplink because I'm streaming the video on the VMS, the IP address, the Ethernet port. It's negotiated at this particular hub is negotiating at 1000 Mbps, which is a gigabit with my laptop, and then system uptime, etc., etc. And we look forward to add some more statistics here to show some more information. So many of the system statistics about the cnVision you are going to be able to see right here inside the VMS. So that's how we offer the VMS integration. So right now, as I told you, we have successfully integrated WiseNet and Milestone X Protect VMS. So you can do the same thing for Milestone. Click on Milestone, have the credentials and the IP address and port of WiseNet, and so that when you uh, trigger an event that generates an alarm, for example, deregistering, the client triggers the event uh, which results in sending an alarm to the VMS. That exact same thing will be seen on the Milestone VMS as well. It's just that the different VMSs have a little bit here and there different things. For example, on Milestone VMS, which I don't have running on my system right now, but we do have it running on our lab system. So it requires you to do special configuration in order to display the events from the cnVision devices. So you need to add the cnVision device as a hardware into the Milestone VMS, and then only you can uh, have that particular device which you added as a hardware uh, send an event to Milestone VMS. So you need to first add the hardware, then go to analytics event and create an analytics event, then go to alarms and link that analytic event to a particular alarm and add the source as the cnVision device which you just added, and then cnVision device will be able to send and the event or an alarm will get displayed on the Milestone VMS. So all these procedures, how to add the analytics event and how to configure uh, the analytics events and alarms on the Milestone X Protect VMS so that you can see the alarms sent by the cnVision devices. All of that will be included in our user guide. And as we add more and more VMSs to this VMS integration part, so we look forward to add Avigilon, Access, and Dahua, Hikvision VMSs as a part of VMS integration in cnVision as well. And we are also open to requests. So if you come up with uh, if you come to us saying that, hey, we are using this particular VMS and we want to use cnVision and we also want to integrate the cnVision devices for that particular VMS, then we are willing to work with you and have that particular whichever VMS you are using, uh, we are willing to integrate it into our cnVision solution. So next thing is status, where it has all this information: device name, frequency at which it's operating, bandwidth, transmit out power, antenna gain, country, IP addresses, etc. So next thing we should do is go to the configuration. Let's go to the configuration first and then come back to quick start menu. So first thing in configuration is radio, where first thing you can see is country. So this particular radio is locked to United States because it is supposed to operate in the United States. Range unit, where you can change to miles or kilometers. SSID, WPA2, pre-shared key, and wireless security option, whether you want to keep it open or WPA2. So as I told you before, all Cambium uh, cnVision devices comes with default WPA2 pre-shared key, which is this string, and it's same for the hub and client. So all you need to do in order to connect clients to hub wirelessly is power them up so that all the clients will connect to the hub, and that's exactly what I have done. So you can see the clients by going to monitor and wireless option. So both these clients are connected to this hub. So I'm going to open the web UI of both the clients and talk a little bit about what you can do with WPA2 pre-shared keys. So let's go back to configuration radio and here. So right now by default you have this default pre-shared key, and we suggest that you should change it to customized pre-shared key. And in order for the clients to connect to the hub, you will need to change it on the clients as well. So during the installation, first step will, if you don't want to pre-configure anything and just have clients receive the IP address via DHCP server, you can do that. Install everything and power up everything so that clients will connect to the hub. Now go to the clients and add this particular hub in the list of preferred hubs. So you add new hub and copy this SSID and check on WPA2. Change this to something. Okay, so after doing this, you will need to hit the save button. And what I was trying to suggest here is you do the same on both the clients and then hit the save button on the clients first, so that clients take this configuration and then change it on the hub and hit the save button. Because if you do it the other way, so if you change it on the hubs first, so if you hit the save button on the hubs first, uh, clients are going to disconnect wirelessly from the hub and they will never be able to connect to the hub because they have different pre-shared key, which is a default pre-shared key. So that's the reason why you should change it on the clients first, hit the save button on all the clients so that after doing this they will disconnect, and then change it on the hub so that next time when they are trying to connect to hub, when they are scanning for the hubs, they will see this particular hub, and when upon trying to connect to the hub, both of both of the clients and the hub will have same WPA2 preset key, and they will be able to establish the wireless uh, connectivity. So that's how you should do it. So I'm not gonna able to I'm not gonna be saving this right now because that was just for the demonstration purpose about of how you configure the WPA2 preset key and uh, hub SSID in the preferred hub part of the client. Okay, so next thing is channel bandwidth. So you can choose between 20, 40 and 80 megahertz, which is a beta quality right now. Here is an option to select the frequency carrier, maximum number of clients allowed. You can limit whatever number you want, maximum range. So if you so this hub 360 uh, is designed to operate between 1 miles and 9 miles. So depending on how far you have your farthest client, so for example, if you have your farthest client 5 miles away from the hub, then you would want to set this number to something like 6 miles just to make sure your farthest client is covered as well. So if you have your farthest client at 5 miles, and if you keep this number at 3 miles, then that any client beyond 3 miles range will not be able to connect to this hub. So next thing is power control. So uh, you might want to so this will be important when you will need to when you need to tackle the problem of the interference. So in usual case scenario, if you don't have any interference, which is the case uh, for me because everything is on the table right next to it, so that and there is no much interference where I'm operating right now, so everything is good and I don't need to worry about the power. But in order to tackle the interference, you may need to play with this parameter and increase the transmit output power so that you have higher stability and your clients will stay connected to the hub. Next thing is scheduler, where you can decide the downlink uplink ratio. So in typical CCTV deployment, you are going to need more frame time for the uplink, and that's why we have pre-configured this scheduler to to be defaulted at 30/70. So 30% of the time is being given for the downlink and 70% of the time is being given for the uplink. We will also have additional option, even though it's not right now, it's on the roadmap, called flexible, where uh, it will be decided dynamically how much time to allocate to downlink and uplink, so that again, in typical CCTV system, you will need more time on the uplink so that most of the frame time will be utilized on the uplink. Let's say, for example, 80 or 90% or 95% on the uplink and only a few percent for the downlink. Next option is wireless MAC address filtering. Upon enabling, you can add wireless MAC filter. So if you want to prevent any client with a particular MAC address from connecting wirelessly to this hub, you can configure that option right here. Okay, so that was about the radio configuration. Let's move on to what we have in system configuration. So system configuration is really straightforward, that you typically don't need to do anything about. So it has the device name and so on and so forth, inactive logout period when you have this web UI open, SSH access, MAC telnet access, Here you can configure your network time protocol, location services, etc. etc. So if you are planning on doing any SNMP, here is for this particular radio, here is the place where you configure your SNMP. Next thing is syslog. So if you have any syslog server running and want to collect logs, then this is the place where you can specify the IP address of the syslog server. Generally, in case of troubleshooting, let's say if you have opened the ticket with Cambium Network support, if we need any additional logs, we may typically suggest you to set up syslog server and have the IP address here and collect the logs in syslog server and send us those logs. Account management. So here you can have you have four types of four levels of the accounts: administrator, installer, home user, and read-only account. So different levels have different access. For example, many of the options which are being seen here or can be changed in this administrator account cannot are not available or cannot be changed if you log in using home user account or read-only account. So that's yep, that was about configuration and systems. Let's move on to configuration network. So here, as I told you, we have statically assigned the IP address to this radio 192.168.0.1 with subnet mask of 255/24. I mean, Ethernet port, Ethernet MTU is set at 1538 and port settings are auto negotiate. Under manual, you have the option of setting port speed manually, but again, we suggest not to do anything because it auto negotiates the port speed to whichever device it's connected to on the Ethernet side. So in advance, we have all these options: IPv6 support, client traffic isolation. So in client traffic isolation, uh, the users below one client will not be able to communicate to the users below other client. You generally, again, uh, in the cnVision solution, this option you don't need to change this option because this is typically for wireless internet service providers. If they are using cnVision or the EPMP platform, on which is a point to multipoint platform on which the cnVision is based, then they typically need to have this option enabled. So I believe none of these options will be required, or depends on your requirement what you want to do with these options. And we will have the user guide for the cnVision where you will have the details about all these options and what they can do. Let's move on to the monitor part. So the first menu here is monitor performance, where you see all the performance statistics about the radio, Ethernet statistics, wireless statistics, and the client statistics about downlink packets, how many capacity packet drops, retransmitted packets, etc. etc. So if you are interested in advanced statistics, you can click enable for advanced statistics, and then you can look through some of the system statistics here, and then what MCS, which is the modulations that your your radio is operating at on the downlink and the uplink, etc. So for the sake of this video, let's not get into all the details about the wireless, as we will come up either with another video or detailed all the details about this on our community forum or in the user guide for the cnVision. So let's move on to the next, where we see all the system statistics about the hardware version, what software you are on, etc. etc. So next and important part for you is monitor wireless. So here uh, you will be able to see the connected clients. So if something goes wrong, that any client drops, then first place where you should come on the hub is monitor wireless and see whether uh, all your clients which are supposed to be connected to this hub are connected or not. So this is the MAC address, IP address, device name, session time, downlink and uplink RSSI, signal to noise ratio, what MCS you are operating at, your downlink quality, capacity, etc., etc., and the firmware version of the clients as well. So all this information you can see in monitor wireless menu. In throughput chart, as I told you before, so throughput chart shows the live throughput of what's flowing through the wireless link. So okay, so here you can see almost nothing is passing through this wireless link at this moment. So you see very small throughput, and of course you will see a lot of throughput on the uplink when we will have the camera feeds running. So next thing is the network. So the things that you configured in configuration network, you are able to see as a part of network monitor menu as well. So the additional part that you see is ARP table and bridge table. So let me quickly go through what they mean. So all the packets coming from any device with any IP address which are supposed to terminate on this particular radio, those entries are added in the ARP table, and this particular radio uh, which is supposed to just transport the packets, for example a video stream or any other kind of user data that just passes transparently through this stream, uh, that corresponds to the bridge table. So next part is the system log. So you had seen that you can configure a syslog server to send the all the system logs to the server, and you can also see them here in monitor syslog, where you need to enable the option and you will be able to see the syslog. Next thing is tools. So first option is software upgrade. So here uh, we will, whenever we have software upgrades, we post it on our website, so you can download those and upgrade these radios from here. Backup restore, where you can back up this configuration and restore it in any other radio. Factory default and backup technical support file. So again, typically if you come across some issue and you have support ticket open with us, one of the first things that we generally ask is to send us the technical support file by coming to this particular option, backup technical support file. Next thing is link test, where you can uh, launch a link test to a particular client. So you can select that client and the duration for which you want to run the test and what packet size you want to have uh, the test run for, and hit start test button. So you can do the link test to see what throughput you are getting on the downlink and the uplink, so that you have the idea of what maximum throughput you are going to get from this particular client to hub. And here in register clients, it shows the exact same details that we saw in monitor wireless option. Next thing is Watchdog. It's kind of a tool for workaround in order to tackle some of the issues. For example, this particular hub is connected to PC right now for me, but if in general case, the hub will be connected to a switch or a router. So what you can do is you can enable the Watchdog and do device reboot or Ethernet restart action, whatever you want, and enter the IP address of that particular switch to which hub is connected from its Ethernet port, and specify your Watchdog ping interval and ping retry. So what this means is if that particular switch or a router is located at some IP address, so this radio is going to ping this particular IP address every 10 minutes, and if it doesn't get response, it's going to retry for 4 times, and if it doesn't get the response, then it is going to reboot itself. So uh, that's how you can use the Watchdog to kind of a have temporary workaround if you face an issue and you are troubleshooting with us. So by the time we fix it, this feature may be useful. A ping is a typical ping tool where you can specify the IP address and ping that particular IP address, and same goes with the trace route where you can specify the IP address and get the number of hops, etc. from the trace route option. Okay. I hope you guys found this video useful and you are excited about the cnVision release. And I also hope that very soon we are gonna go out of stock with your overwhelming purchase order for the cnVision devices with such cool features for the cameras and VMS. So that brings us to the end of this video. Thank you all for watching and have a wonderful rest of your day.